All right, this is Honors Geometry, section 7.5 on parts of similar triangles. And the question to begin with is, how many words can you put into this blank that make it a true statement? So if two triangles are similar to each other, then their corresponding what are proportional to the lengths of the corresponding sides. So I have these two triangles here, and I'm saying that these two triangles are similar to each other, and A over D is our established proportion because those are corresponding to each other. That's equal to B over E, that's equal to C over F. And if I draw in the corresponding altitudes, called this length X, called this length Y, X over Y is that same proportion. Or if we draw in the corresponding medians, for example, from this segment, I draw the median to that opposite side. And from this vertex, I draw the median to that opposite side. And I call these lengths X and Y. That X over Y proportion is equal to all those other ones as well. So we have the corresponding altitudes, medians, perpendicular bisectors, angle bisectors, the corresponding midsegments, as well as their perimeters. And that's probably the most important one for us. If I find the perimeter of this shape on the left and the perimeter of the shape on the right, that ratio of big divided by small is going to be equal to the A over D or B over E and C over F. So that's going along with the properties of similar triangles we had before. The next theorem we have is derived from that. We're not actually going to full up prove it in this video, but what I'll tell you is that when you have a triangle and there's an angle bisector of a triangle, it splits this opposite side in a proportion such that AB divided by AP is equal to BC divided by PC. So I could say, oops, I have these markings on here wrong. Double, single. Double over single equals double over single, or double mark over double mark equals single mark over single mark. Remember, we have a lot of properties of proportions. We could cross multiply and divide by various things to show other versions of this. But when you have this angle bisector, I'll go to colors, yellow divided by yellow is equal to orange divided by orange. An example of how to use that. So we have BD as the angle bisector. So put those little markings on there. The length of AD is equal to 8. The length of AB is 20. And the length of AC is 22. Now, if this entire length is 22, this much of the segment is used up by the 8. That means that this length is going to be 14, and we're trying to find the length of BC. At this point, I'd encourage you to pause the video and try it on your own. When you're ready, you can come back and check. I know that 8 over 20 is going to be equal to 14 over x. Now, one thing I can do is simplify down this fraction, divide by 4, so smaller numbers, that's great. Now we'll cross multiply, 2x is equal to 70, divide both sides by 2, so x, the unknown side of BC, is equal to 35. So that's really the only new thing in section 7.5. The rest of the things that I have in here are just some review examples from previous ones. So let's go ahead and take a look at this one. A dog and a puppy together weigh 28 pounds with the ratio of their weights being 5 to 2. What is the weight of the puppy in pounds? So the puppy is going to be 2x. The dog is going to be 5x. Together, they add up to 28 pounds. 7x equals 28. X equals 4. That doesn't mean the puppy weighs 4 pounds. You're going to plug that back in for our puppy expression, and the puppy is going to weigh 8 pounds. Next one. For this one, highly encourage you to draw in the two triangles. And I'll try to make them look somewhat similar to each other. Definitely have the same orientation. So A, B, C, E, F, G, looking something kind of like this. Angle A is 3x plus 2y. Angle B is x minus 5. And angle C is 101 degrees. Going over to the other triangle, measure of angle F is 2x over 3. And from this drawing, it's really obvious to me right away that these two angles are going to be equal to each other. So x minus 5 is equal to 2x over 3. How about we multiply everything by 3? 3x minus 15 equals 2x. Subtract 2x from both sides, add 15 to both sides. We get x equals 15. There is one of our answers. Now, to keep going with this one, if x equals 15, I still need to figure out y. So if we look at this triangle, angle C was 101. If x is 15, that means that this angle down here is 10 degrees. 101 plus 10 is 111 degrees. That with this 3x plus 2y have to add up to 180. So I can take 180 minus the 111, and that's going to come out to 69 degrees. So that means that 3x plus 2y is equal to 69. I already know that x is 15. 3 times 15 is 45. Plus 2y equals 69. Subtract 45 from both sides. Divide by 2, and we get that y equals 12. All right, here's our next example. So again, if you haven't been doing it, probably want to pause this and try it on your own first, and you can start watching it to see what the answer is and listen to the explanation if you need some help. AB parallel to CD. The length of AB is 4, BE is 2, AE is 3, and DE is 5. Now, because of the parallel, I know this whole shape is a trapezoid. I know that this alternate interior angle is equal to this one. These alternate interior angles are equal. And then, of course, these vertical angles are going to be equal to each other. What that gives us is this green triangle, similar to this blue triangle. And it's kind of twisted around a little bit. So as I'm looking for CD, this length across the bottom, I can tell that the x is corresponding to the 4. So blue over green is in the ratio of x over 4. And the 5 is coming out of the blue. The question is, what is the length it's corresponding to in the x? Well, I see that the 5 from this blue is opposite the angle with 1 mark. So if I go up here to the green, opposite the 1 mark is the length of 2. So there's my proportion. Again, it's kind of twisted. This 5 is going to the 2. From here, we're going to cross multiply, divide by 2, x equals 10. The length of CD is 10 units long. Number 4, IT bisects angle BIS. So once again, I'll put those little markings on there. IB is equal to TS. That's kind of interesting. So here is x. Here is x. I'm just inserting this temporary variable. It's going to make it easier for me to write an equation. BT is 4, and the length of IS is 12. The question is to find the perimeter of triangle BIS. This is that triangle angle bisector theorem where we can say that 4 over x is equal to this x divided by 12. If we cross multiply, x squared equals 48. Take the square root of both sides. Square root of 48 breaks down to 4 root 3. So now going to the entire perimeter, we have 4 root 3 plus 4 root 3 plus 12. If we combine like terms, there's 16 plus 8 root 3 for the perimeter of triangle BIS. Number 5, find the ratio of y to x. To begin with, we have a proportion, so I'm going to cross multiply. 24 plus 3y is equal to 24 plus 2x. How about we subtract 24 from both sides? And because we want the ratio of y to x, that means like y over x, let's divide both sides by x. Also divide both sides by 3, so that's off the left, this is off the right. Y over x is 2 over 3. So the ratio of y to x is 2 to 3. You can write it as 2 over 3 as well as a fraction. It doesn't really matter. A lot of times we see ratios written like this, but 2 over 3 is the same thing. Next example, trying to solve for x and y. Because of angle-angle similarity, I know that blue triangle and orange triangle are similar to each other. So from here, we're going to write a proportion. In the blue triangle, there's a length of 3. That corresponds to a length of 4 in the orange triangle. Also in the blue triangle, there's a length of x, which corresponds to the length of 8 in the orange triangle. Cross multiply, 4x is equal to 24, so x equals 6. There's one of our answers. The other thing that I see here is that the orange triangle is similar to this pink triangle. So looking at this proportion, the length of 3 in the blue is corresponding to 7 out of the pink. So blue over pink equals the length of x in the blue, I know that's 6, divided by the pink length of x plus y, which would then be 6 plus y. Cross multiply. 18 plus 3y is equal to 42. Subtract 18 from both sides. And lastly, divide both sides by 3, so y is equal to 8. Now we have x and y. Next example, solve for x. Solve for x. There's 3 triangles here, but the good news is that 2 of these triangles are similar to each other. Gray triangle has an angle with a double mark and a single mark in it. Blue triangle has a length with a single, or has an angle with a single mark and a double mark in it as well. So those 2 triangles are similar to each other. Let's start with the gray. The gray has the length of x in it. X is the side in between the double and single markings. So in the blue triangle, it's corresponding to the side between the single and the double markings, which would be the entire length TS. 7 plus 9, that's 16. So gray triangle to blue triangle, x over 16 is equal to, we'll go back to the gray triangle, across from the double mark has a length of 9. So then if we go to the blue triangle, across from the double mark, that length is going to be x. So again, the blue triangle across from the double marking is our x. Cross multiply, x squared equals 144. So x is plus or minus, but the negative doesn't make sense. So x equals just positive 12. Next, triangles ABC and DFE are similar. The order of this similarity statement is significant to us. A is corresponding to D because they're the first letters. B is corresponding to F, they're the second letters, and then C and E. Or AB and DF are going to be corresponding. BC and FE. And then lastly, AC is corresponding to DE. As far as the lengths go, AC is 8, BC is 9, AB is 10, and lastly, EF equals 12. We're not asked to find the lengths of all of the sides in the second triangle. We're just asked to find the perimeter of it. And I could find all of these sides and then add them together to get the perimeter, but the more efficient way is to use the ratio of the corresponding sides between these similar triangles is equal to the proportion between the perimeters of these similar triangles. In other words, the perimeter of the smaller one, 10 plus 8 plus 9, is 27. The perimeter of this one divided by the perimeter of triangle DFE, so the ratio of their perimeters is equal to the ratio between the corresponding sides of 9 over 12. So the only unknown in this equation is the perimeter of DFE. Before I cross multiply, I'm going to divide by 3 over here, with smaller numbers. So 3 times the perimeter of triangle DFE is equal to 27 times 4. I believe that's 108. Divide both sides by 3, and we get the perimeter of triangle DFE is 108 divided by 3. That's 36 units.